Hello. 안녕하세요. 오늘은 좋은 날입니다. Hi everyone. My name is Thomas Kim. Today is June 24th, 2022. This is my 12th episode for C++ 17, 2023 and other programming technologies. In this episode, I will discuss Dependency Flow Graph. Intel TBB Flow Graphs provide us with two parallel programming patterns. One is Message Flow Graph. The other is Dependency Flow Graph. In my previous episode, I asserted that once you can generate your data using input node and or broadcast node and feed those data into your function nodes and split or join the data, you understand at least 80% or more of TBB Flow Graphs. In this episode, we will learn how to use Dependency Flow Graph. This Dependency Flow Graph is super powerful and super simple and easy to understand and use. So, this Dependency Flow Graph fills 10% of the TBB Flow Graphs. If you watch through the end of this video, you can say you understand 90% or more of Intel TBB Flow Graphs. If you are not convinced after this video, please leave your comment rebutting my assertion. More specifically, from oneAPI specification, this link. This is oneAPI specification version 1.1 revision 1 documentation. Scroll down, you can find oneTBB. Click this button. oneTBB interfaces. Click this button. Flow Graph. Click this button. In this submenu, you can find Message Flow Graph Example. We already learned how to use Message Flow Graph. In my current episode, we will learn Dependency Flow Graph. Dependency Flow Graph is super simple and easy to learn and use. So we will examine this sample code. I would like to recommend for TBB C++ parallel programming with threading building blocks. Please double-click this link. From this website, you can download TBB PDF book by clicking this link. Also, using this download link, please double-click it. Go to Code, Download Zip, Show in Folder, unzip it. Rename it 000 TBB Master. Cut, paste it to your working directory. So, this TBB Master is sample files, Chapter 1 through Chapter 20 and Appendix B. If you download TBB by clicking this link, you can get TBB, this PDF book, free of charge. In Chapter 3, explains about flow graphs. If you watch my video faithfully in this session, you can exploit dependency flow graph in your parallel programming. To follow my current session, I assume you have watched my previous videos listed in this playlist. Of course, you should have installed Intel oneAPI threading building blocks. In our previous episode, episode 11, we learned how to use split node and join node. Now, show more from episode 11. Please click this link. Show in folder, unzip it, rename 012 Dependency Graph. Double click this folder, copy, paste, rename dependency. Go up, copy this folder, copy, paste it in your working directory. Now start Visual Studio Code, open CPP 172023 parallel from folder 012, double click dependency.cpp, Ctrl B, Ctrl Home. Scroll down. From test broadcast node, we will delete. I will copy and paste this link. If you Ctrl click this link, you have this web page. I would make the menu hidden. I will arrange like this. If you scroll down, you can see the sample code. Void test dependency graph. Int main, copy this function name, paste it in your function main. I will scroll up. Here we are defining this struct body like this. Struct body, don't miss semicolon here. Std string my name. We need to make constructor body. It takes constant character pointer name. We initialize this member my name by passing name. Then we need a block for constructor. Void operator, we define function call operator. Please remember flow, continue, message. This is a type. This is type. It should be constant. Make a block. We will simply print out my name. And there. So we defined body. It has a function call operator as its member. Don't forget constant here. Now flow graph. We define graph. Flow broadcast node. We define flow continue message. This is type. Continue message is type. We define ND. ND means node. Start. By passing graph as its argument. Now scroll up. In this diagram or dependency graph. ND start. This is our broadcast node. Its template parameter is continue message. Now we define node A. This node is flow continue node. It takes flow continue message as its template argument. Then ND A. This is node A. The first argument graph. The second argument body. We will use this constructor. We are calling this constructor body like this by passing A. Don't forget semicolon. We will be using this all the time using continue node T define like this because we are going to use this all the time. Continue node T node B, we pass G, then body, this is B. We defined this node B. Copy, paste, 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 paste. This is node C, its name C. Node D, its name D. Node E, its name E. Node, this is superfluous. If you don't like this way of programming, you can always specify the full name here if you want to. Anyway, we defined node A, node B, node C, node D, node E. We defined all nodes. Now we create edges. 1, 2, 3, 4, 5, 6 edges. So flow make edge from start to A. ND start ND A. Copy paste from start to B. ND B. Paste from A to C. ND A to ND C. Copy paste from B to C. ND B, ND C. Copy paste from node A to node E. A, E. Copy and paste from C to D. C to D. 1, 2, 3, 4, 5, 6 edge. So 1, 2, 3, 4, 5, 6 edge. We defined all the edge. Now scroll down. Here for int I would make it here context per auto and 10. scroll down. I from 0, I less than n plus plus I. We are implementing this part. And the start, try, put. Please understand that and the start, this node, defined here, broadcast node, takes continue message as its argument, like this. As I said, this is type. We are calling function, so we have to pass an instance, like this. Then we have to wait. Now I will make it smaller. Start your command prompt. dir cd 012 dependency graph clang std c ++17 dependency.cpp ltbb 12. You should not forget this switch. c.exe, hit enter. Wow, it built CLS-C. We have some weird message. Please understand that we named A, B, C, D, E. A, B stuck together. A, B stuck together. B, A stuck together. B, A stuck together. E, C stuck together. Now go up. In this dependency flow graph, A and B are independent. They are not connected. So A and B can run asynchronously. In the same manner, E and C can run asynchronously, concurrently. So B can execute prior to A, or A can execute prior to B. In this case, B is executed prior to A. Okay? In this case, A is executed prior to B. This is bug. So we want to address this issue. How? Like this. TBB concurrent vector LCD string. We say names. Now scroll down. Here we delete this names in place back my name. Please note that this body can run asynchronously. Several instances of this body, especially this operator function, can run concurrently. However, we don't need synchronization code here. We do not use mutex or atomic because we are using concurrent container. Wow, so smart. Now scroll down. Here, print names. We flush out to console. Now we build again. Here, CLS-C. Now it runs beautifully. So we will put some message here, like this. talk, play, fun, S stream, message, we put carriage return, stage, then I, names, in place back, MSG, str. This SS stream is super useful. Now we build again. CLSC, wow, beautiful. At stage 0, A, E, B, C, D. This is the execution order. A, E, A, E, B, C, D, B, C, D. A and B can run asynchronously, so A can be executed prior to B, or B can be executed prior to A. But E is dependent. E is dependent on A. A is its predecessor, or A has successor E. So A always precedes E. E always follows A. A always precedes E. A always precedes E. A always precedes E. A always precedes E. Okay? In this case, B has successor C. C has predecessor B. B always precedes C. C always precedes D. So, B always precedes C. C always precedes D. B always precedes C. C always precedes D. The execution order is properly maintained. Also note that E and C can execute asynchronously. E can precede C. C can precede E. Between C and E, or between E and D, the execution order is not defined. Now, here, some work. For example, if my name equals E, this instance E, then std, this thread sleep for 1 US. We need using namespace std chrono literal. To use literal US or microsecond, we need to declare namespace std chrono literals. So this E node sleeps 1 microsecond each time. Now we build again. CLSC, or we can make it big, or we can make it even millisecond. We rebuild CLSC. Wow! See? DE. E and D are independent. C and E are independent. A always precedes E. A always precedes E. So in this result, E is always the last executed. Or we can make it 10 microseconds. Let's see how the result different. Now This is the execution result. This flow graph is super useful. It enforces the order of execution all in parallel or asynchronously.